Alright, chapter 7, section 1, we're going to learn about inverse variation. So this book just assumes that we already know what direct variation is, which you probably did it in Algebra 1, may not remember, but our formula for direct variation is y is equal to a times x, where a is some constant. So the opposite of this would be inverse variation, which we have this formula here, y is equal to a divided by x, where again a is some constant. So a little bit behind inverse and direct variation is direct variation as x increases, y also increases, so they directly go the same way. Inverse variation, as x increases, y decreases. So it's the opposite. If x decreases and they vary inversely, then y would increase. So example 1, we need to determine if they have direct variation, indirect variation, or neither. This got cut off, but it should say neither. So we want to solve all of these equations for y, and see if we get our equation to look like y is equal to a over x, because this would mean we have inverse variation, or if we get our equation to look like y is equal to a times x, because this would be direct variation. If we can't get it to look like either of these, then it's going to be neither. So let's look at example A. We want to solve for y, so what do we have to do to get y all by itself? Divide by x. So we have y is equal to 5 divided by x. Which equation does this look like? Inverse. So this is inverse variation. For B, we already have y is equal to. Does this look like our inverse variation or direct variation? Are we multiplying x times a constant? No. So what do you think it is? Neither. And then for C, how would we solve for y? Multiply 2 on both sides. So we get y is equal to 2 times x. So which equation does this look like? Direct variation. We're doing the same thing for this page, so we want to solve each equation for y. So number 1, we already have y is equal to. So y is equal to 6 times x. Is this direct variation, inverse variation, or neither? Direct. We're multiplying x times a constant, so this is direct variation. Number 2, we have to solve for y. So what do we need to do to solve for y? Divide by x. So we have y is equal to negative 0.25 over x. Is this direct variation, inverse variation, or neither? Inverse. We have inverse variation here. Number 3, how do we solve for y? Subtract x on both sides. So y is equal to 10 minus x. Is this direct variation, inverse variation, or neither? Neither. Any questions here? All right, in our next example, again, we are determining if we have direct variation, inverse variation, or neither. And a way we can figure this out when we are given 2 sets of data, so we have values for x and values for y that are given to us, is we have to find x times y and y divided by x. if we find x times y and we get a constant, then we have inverse variation. If we do y divided by x and get a constant number, then this would be direct variation. And the reason why it's a little bit different than the formulas that were given to us on the second slide is our formula for inverse variation is y is equal to a divided by x. So here we're solving for our constant a. How would we solve for our constant? What do we need to do? We're solving for a. Multiply both sides times x. So we have x times y is equal to a. So inverse variation, we start off dividing, but it's actually just x times y. So just got to be careful with that in this part because it looks a little bit different. Same thing for direct variation. We have y is equal to a times x. How do we solve for our constant a? Divide by x. So we get y divided by x is equal to a, so that's how we go from dividing, which is our direct. So just got to be careful with these. So multiplying x times y, if we get a constant, that's our inverse variation. If we divide and get a constant, that's our direct variation. So we got to first multiply x times y. So what do we get when we multiply 2 times negative 12? Negative 24. What do we get when we multiply 4 times negative 6? Negative 24. What do we get when we multiply 6 times negative 4? Negative 24. And 8 times negative 3? Negative 24. So since we got a constant here, we have x times y variation, which what does that mean? Is this direct variation, inverse, or neither? Inverse variation. If we didn't get a constant here, then we would have to divide them and check for direct variation, but you're not going to have inverse variation and direct variation, so once you get inverse, you don't even have to divide them. So you're looking for a constant number all the way through. So let's do B. First, we want to multiply them and see what we get. So it's 2 times 1. 2. 2 times 4. 8. 3 times 8. 24. And 4 times 16. 64. Is this a constant? Nope. So we do not have inverse variation here. Next, we want to check for direct variation. So we have y divided by x. So we have 2 divided by 1, which is what? 2. Next, we have 4 divided by 2, which is 2. Then we have 8 divided by 3. Can we simplify 8 divided by 3? Nope, so it's just 8 divided by 3. And then we have 16 divided by 4, which is 4. Is this a constant number? Nope. So y divided by x does not work. So if we don't have inverse variation or direct variation, what do we have? Neither. Any questions here? All right, 2 more examples. First, we want to check y times x times y. What is 20 times negative 4? Negative 80. What's negative 3 times 15? Negative 45. We already got different numbers, so obviously this is not going to be a constant, so x times y does not work. We can keep multiplying them and just check them all, but it already didn't work, so if you just want to do it until you get a number that's not the same, or you can check all the way through. Next, we need to check y divided by x. So we have 20 divided by negative 4. What's that? Negative 5. Then we have 15 divided by negative 3. Negative 5. And 10 divided by negative 2. Negative 5. And 5 divided by negative 1. Negative 5. So we got all constants here. So what does that mean? What type of variation do we have? Direct variation. Any questions on that one? All right, number 5. Let's multiply them. X times y. What's 1 times 60? 60. What's 2 times 30? 60. 60. 60. So what type of variation do we have here? Inverse. So since x times y works, we don't even have to check y divided by x because we already have inverse variation. Oops. Alright, next we're going to be writing inverse variation equations. What is our formula for inverse variation? Y is equal to a over x. So in these types of problems, it's going to give us a value for x and y, and we need to solve for a. We have to find what our constant is. Then we plug that into our equation with x and y, so we have our inverse variation equation, and then we can find whatever value it gives us. So this is asking us for two different parts of this problem. So first we want to write an equation that relates x and y. So we need to find what a is. So we want to plug in 4 for y and 3 for x. So we have 4 is equal to a over 3. How do we solve for a? Multiply 3 on both sides. So 3 times 4 is 12. A is equal to 12. Now we want to plug that back into our inverse variation equation up here. So we have y is equal to 12 over x. This is our equation that relates x and y. Next, we want to find what y is when x is equal to negative 2. So what do you think we have to do next? Awesome. We just plug negative 2 in for x. So we have y is equal to 12 divided by negative 2. What's 12 divided by negative 2? So y is equal to negative 6. So this is our answer to our first question. It's our equation. This is the answer to the second question that it asked. Any questions here? All right. So again, it tells us that they vary inversely. So what is our formula for inverse variation? Y is equal to what? A over x. So we're going to take the x and y that it gives us, plug it in so we can find a. So we have 5 is equal to a over x, which is 4. How do we solve for a?
Multiply the 4 on both sides.
Multiply the 4 on both sides. So we have 20 is equal to a. Now we just need to plug that into our equation. So we have y is equal to 20 divided by x. That's step 1. That's our equation. Next, second part of this question says find y when x is equal to 2. So what do we do with 2? Where do we put it?
Plug it in for x.
Plug it in for x. So y is equal to 20 divided by 2. What's y equal to? 10. Any questions on that one? Alright, 7. What do we do first? Negative 1 is equal to a over 6. So we have to solve for a. How do we solve for a? Multiply 6 on both sides. So we have negative 6 is equal to a. Awesome. Y equals negative 6 over x. So we plug that in. Y is equal to negative 6 divided by 2. Y is equal to negative 3. Alright, number 8. What do we do first?
$16 is equal to A over 0.5.
16 is equal to a over 1/2. You can use 0.5 if you want, doesn't matter. Same thing. How do we find what a is?
Multiply 16 and 1/2, which is 8.
Multiply both sides by 1/2. 1/2 times 16 is 8. So 8 is equal to a.
Y is equal to 8 over 2.
Y is equal to 8 over x first. Then we plug in 2. So y is equal to 8 over 2. Y is equal to 4. So this is where we're going to stop for today. We're going to do the word problem tomorrow. So this is 7.1 part 1. You don't have to turn in the notes, but you can get started on the homework.